Hello students, welcome back to this new session on mathematics. I have come up with one more problem on Laplace transform of a periodic function. The question is as shown on your screen. If f of t is equal to t when t is in the interval 0 to a and 2a minus t in the interval a to 2a, and it's clearly written that f of t plus 2a is equal to f of t, then you'll have to show that L of f of t is equal to 1 divided by s square tan hyperbolic as by 2. Okay, let's prove this by a simple solution. The solution goes as, and all of you, I request all of you to take a pen and a paper and start working for the problem with me. Okay, just follow the video and start working with the problem. Okay, for the problem here. Okay, so now it's clearly shown that the period of that function f of t is 2a. So you can write first given. What is given to you? That capital T is 2a for you. Is it? Now, since it's a periodic function, now in my previous sessions also we have completed what is the Laplace transform of a periodic function. We have derived one big formula, one big derivation was there, and apart from that at the end we got the Laplace transform of a periodic function. So what is that? The Laplace transform of any periodic function f of t is equal to, that is L of f of t for any period t, you have 1 divided by 1 minus e to the power minus st. This capital T gives you the period, and integration from 0 to capital T again. This capital T is again the period of that function, e to the power minus st f of t dt. This is the Laplace transform of a periodic function. So with the help of this, here we have got capital T as 2a. So let us substitute. So for this given problem, the Laplace transform of f of t becomes what? 1 divided by 1 minus e to the power minus s. In place of t you should have 2a because capital T value is 2a. So integration from 0 to 2a, e to the power minus st f of t dt. I hope it is clear. I have just substituted the value for capital T, nothing else. Now, this is equal to 1 divided by, let us simplify this further. It is 1 divided by e to the power minus 2as. I can write it like this. 1 divided by 1 minus e to the power minus 2as. Integration. Now here, just have a look on this integral. It is integration from 0 to 2a, e to the power minus st f of t dt. Now what is this f of t? It is the f of t defined in this problem. Okay, now in this problem the function f of t is defined in two ways in this interval only, from 0 to 2a. The complete interval is 0 to 2a only, and in that interval it has been defined in two ways. It is first t in the interval 0 to a, and next it is 2a minus t in the interval a to 2a. Is it not? So we will split this integral as per the definition of this f of t. We will split this integral as per the definition of this f of t. So let's do that. So it will be equal to, 1 minute, yes, it is, take a bigger square bracket, integration from 0 to a first. In this interval 0 to a, e to the power minus st, f of t is taking the value t dt, plus under integral a to 2a, from the interval a to 2a, it is taking the value e to the power minus st as it is taking the value 2a minus t into dt. Complete your square bracket. I hope it is clear up till here, all of you. Yes. 1. Now, this is equal to, now see, we have to separately integrate these two integrals. Okay. So keep this outside thing, that is 1 divided by 1 minus e to the power minus 2s as it is in the square bracket. What is the integration of this? You have to integrate it by parts or just apply Bernoulli's rule. Now I have taught you what is Bernoulli's rule in the beginning of this module itself. Okay, so here I'll be directly using it. Okay, so all you have to do is you have to select your u and v in such a way that your term gets vanishes. For example, if you see what is Bernoulli's rule, I'll just write it in short so that you should understand in this here. So we have suppose two functions u and v of the same variable, and we have to integrate it by parts, u into v. So its integration is given to be u as it is, integration of v minus under u dash, derivative of u and double integration of v, plus Earlier it was minus, now it should be plus. U double dash, that is derivative of u, second derivative of u again, that is u double dash. Then third integral of v. Again, since it is plus here, now it comes minus. So this is your Bernoulli's rule. It continues further. Triple derivative of u and fourth integral of v, and so on. So this is the Bernoulli's rule. In short, I have written it here. If you have not understood, you can just refer even the previous session. There also it will be clear. Okay. Now, you have to select your u in such a way that after certain number of derivatives it should vanish. Okay. Now it's clearly the t. When you differentiate it once, you will get 1. After that, if you differentiate, it will be 0. Is it not? Similarly, here, if you differentiate, it is 2a minus t. A is and 2, both are constant. So 2a is constant. So you can select this as u. Here also this as u. So use this as u, this as u, this complete bracket as u. Okay, and then apply this Bernoulli's rule, you will end up with integration within no time. Okay, now let us go for that. So you have u as it is, means t as it is, integration of e to power minus st. It is e to power minus st divided by minus s. Is it not? Minus. Now derivative of u, that is u dash, you write. Now derivative of u is derivative of t. Is it not? Derivative of t with respect to t is 1. Similarly, double integration of v. This is your v now. Obviously, when this is u, this is v. I have not told you, but it should be understood that when this is u, this should be v. Okay, because there are two functions for us. Okay, now this t as it is, integration of v, we are done, minus derivative of u, which is t. Derivative of t, which is 1. Now double integration of v means what? Whatever you have integrated here, the same you have to integrate this once again. So what do you get? E to the power minus st divided by minus s whole square you get. Is it not? Minus s already you have, one more minus s you will get. So why you will write minus s whole square. Now this is the integral of the first part, first integral. Now further if you do these terms, the derivative of one term is 0. So no need not write the further terms. So I'll just cover up them in one simple bracket saying the limits going from t from 0 to a. Now plus, now let us do the same thing for the next part of this integral. Now see here, take again a small simple bracket. Now first u as it is means 2a minus t as it is. Integration of e to power minus st, e to power minus st divided by minus s minus derivative of 2a minus t. Derivative of 2a with respect to t is 0. Derivative of minus t with respect to t is minus 1. You will get it like this. Now again integration, double integration of this means what? You have to integrate this bracket once again. Already you have integrated v once here. Now double integration means what? You did not see this to double integrate this. You just see the previous integral. Here, integrate this only with respect to s. So what do you get? E to power minus st divided by minus s square you get or no? Like same as over here. Okay. Now complete that simple bracket which you had started here. T going from a to 2a. Complete the bigger square bracket which you had started here also. Just do it in a better way. Okay. This is how you do it. Now let us substitute the upper and lower limits for both the integrals. It is 1 divided by 1 minus e to power minus 2as. Take a square bracket. Now if you are putting, let us substitute the upper limit for these two first. Okay. So t is equal to a means a into e to power minus sa divided by minus s. Okay. Now minus s whole square becomes plus s. Here it is minus, so minus e to power minus sa divided by s square you get. This is the upper limit for the first term. Okay. Minus the lower limit. When you put t as 0, this becomes 0. Okay, because t is 0 here. Next, when you put t as 0, minus e to power 0 which is 1 divided by s square you get. This is one thing. Okay. This is the lower limit for the first term. Next, plus upper limit for these two terms. So when you put t is equal to 2a over here, 2a minus 2a becomes 0. The bracket turns 0. So this into that again turns 0. E to power 2a into s it will be here. But here 2a minus 2a becomes 0. So the upper limit for the first term is 0. For the second term, minus of minus plus. Okay. You are putting t is equal to e to power 2a. So e to power minus 2as divided by minus s square, it is plus s square. Okay. This is the upper limit for the second term. Minus the lower limit. When you put t is equal to a, here it will be 2a minus a, which will be a e to power minus sa divided by minus s. This is the lower limit. Here minus sign is also there. So please take care about that also. Now here when you put t is equal to a, minus of minus plus again, lower limit sign is already there. So don't do anything for that. So minus the lower limit we are doing, we are putting t is equal to a. So 2a minus a is a e to power minus as divided by minus s. And here minus of minus plus again. Now you put t is equal to a e to power minus sa divided by s square. Complete the bigger square bracket which you have started here. Okay, now let us sum up all the terms together which do have same type of denominators. Okay, now see here. Here you have minus sign. You can take that minus sign above. Okay, just see. The minus sign which is there here, you can take it above and write it as minus a into e to power minus as divided by s, minus e to power minus sa divided by s square, minus of minus plus 1 divided by s square, plus e to power minus 2as divided by s square. Now here it is minus into minus plus a into e to power minus as divided by s, and minus into plus, it is minus e to power minus as divided by s square. Now as you see, minus a into e to power minus as divided by s and plus a into e to power minus as divided by s, these two terms will get cancelled. The only term which is having the denominator s square will be left. So let us collect all those terms. So you have 1 divided by 1 minus e to power minus 2as in the bracket. Look at this, what terms we have? It is 1 minus, first denominator is common, it is s square. I am going to write it first together. Okay, first do that. Then this one I am writing it here. Next, minus e to power minus sa minus minus e to the power minus sa minus e to power minus as or sa, both one and the same. So it becomes 2 into e to power minus as. Is it not? Plus these two terms are simplified. Even this is there, only the remaining term is this e to power minus 2as. Okay, complete the bigger square bracket. Okay, now this is equal to, I'll just sum up it here only. So it is 1 divided by s square. This is nothing but, can anyone tell me what is this? Is it not in the form a minus b whole square? Look at this, you can write this as, in place of a as 1, b as minus, e to power minus as. Okay, if you just consider this, it is nothing but a minus b square form. Okay, a minus b the whole square form. So here it is 1 minus e to power minus as square divided, this complete thing is that, and the denominator is 1 minus e to power minus 2as. You have something like this. Okay, now look at the denominator. Even this denominator is in the form a minus b into a plus b form. It is something like a square minus b square form. Okay, it is something like a square minus b square form. I hope it is seen there. See, if a is equal to 1, first check about the numerator, this bigger bracket over here. If you put a is equal to 1 and b is equal to e to power minus as and consider a minus b whole square, you will get this bracket c. Is it not? It means what? It is 1 minus e to power minus as whole square. The numerator is this. Similarly, for the denominator, look at the denominator. It is in the form a square minus b square. The same value for a and b. The same value for a and b which I have written here. Okay. So this is nothing but 1 minus s square, 1 minus e to power minus as whole square divided by, here you will have two brackets. 1 minus e to power minus 1 minus e to power minus as into 1 plus e to power minus as. Okay, so one of these two brackets, this and one bracket from here will get cancelled, see. Okay, so you will be left with what? I shall write it here. So it is 1 divided by s square as it is, 1 divided by s square as it is, and one bracket here e to power minus as over 1 plus e to power minus as. Something like this you will be left with. Okay, now you divide and multiply. For this term, you divide and multiply by e to power as by 2. Divide and multiply by e to power as by 2 over here. Okay, so I will say divide and multiply by this thing to this. Okay, a note over here. Okay, divide and multiply by this to this term so that you get the required answer. Okay, so as I told you from my last step, that is your L of f of t, you had stopped it up till here. Now you have to do one small step here, divide and multiply by e to power minus plus as by 2. So why this term over here? Okay, just see over here, look at the numerator, you have 1 minus e to power as by minus e to power minus as, and in denominator you have 1 plus e to power minus as. I somehow want the answer to be 1 by s square tan hyperbolic as by 2 I want. Is it not? But I have got as over here. Yes? And you have even studied the formula for tan hyperbolic in terms of exponential functions. Okay? So what is tan hyperbolic as by 2? You know that it is e to power as by 2 minus e to power minus as by 2 over e to power as by 2 plus e to power minus as by 2. Okay? This is tan hyperbolic. So I want to reduce this to this pattern. Okay, so let us do that, because tan hyperbolic you should even know this also. You can, if you don't remember this, you can obtain it by basic formulas of sine hyperbolic and cos hyperbolic. This is nothing but sine hyperbolic as by 2 over cos hyperbolic as by 2. Yes or no? Using this, yes. So just to do that, so if you substitute the value for sine hyperbolic as by 2, it will be e to power as by 2 minus e to power minus as by 2 divided by 2. Divided by cos hyperbolic, you know already the value, just get the plus sign in between and you get it. So you want that in this form. So just see what you have to obtain. Now you have this, how can you reduce it? Means what, you have 1 over here, if I multiply it by e to power as by 2, I'll get e to power as by 2 over there. And similarly, if I multiplied it by that, so what do you have? E to power minus as into e to power as by 2. What you will get? What you will get? So you will get this as, yes, just multiply these two. You will get e to power minus as plus as by 2. Is it not? So what is it? It is e to power minus as by 2 or no? Minus 1 plus half. Okay, it becomes minus half. Okay, so this pattern will work over here. So now this is 1 divided by s square. Let us simplify this further. 1 minus e to power as by 2 divided by 1 plus e to power minus as by 2 divided by, okay, here we are multiplying and dividing. So let us first multiply here and divide. This is divided by. Means what, even if you cancel this, both will get cancelled, you will get back the same thing. But when you are dividing and multiply this inside this bracket now. It is 1 divided by s square, e to power as by 2, multiply this inside. E to power minus as by 2. I have told you how do you get this e to power minus as by 2. Just see that you have to multiply these two. Okay, you get that. E to power minus as plus as by 2 plus e to power minus as by 2. Okay, just multiply this here in the denominator also. You will get back this. Okay, now once you get this, now I have explained this, how it is this. So 1 by s square as it is. This is nothing but tan hyperbolic as by 2 as per the required solution. This completes your problem. I'll continue in my next session with some more problems. Okay, but before that, I just want to give one more problem for you as homework. Take down this. Yes, here I'll give one more problem for you as homework. Given f of t is equals to e when 0 less than t less than a by 2 and minus e when a by 2 less than t less than a, where f of t plus a is equal to f of t. Now here the period is a, that is capital T is equal to a. Taking capital T is equal to a and splitting your integral, like how I have done in my previous example, the same way you are going to follow the steps and get the solution. Okay, so just work for this and share your solution in my WhatsApp group. Okay, take this as homework, work for this properly and share your solution. Okay, if you have any doubt, please do ask me. Okay, thank you.